Now recording. Okay, so we are moving on from geometry. Today we're starting ratios and rates. And yes, that is not the word radio, that is ratio. Okay, we want to get these definitions down and then talk about what they mean and how we're going to use them. Okay, so definition of a ratio is a comparison of two quantities by division. So a comparison of two quantities by division. And a ratio can be written three different ways, and any three are going to be acceptable unless it tells you it wants one specific form. So just using the numbers 2 and 3, we can write a ratio as 2, the actual word 2, and 3. We could use a colon. What do you do in English, or what have you studied this year in English that you write with a colon? Analogies. Okay. What is an analogy? Comparison, right? So with ratios, you're doing the same thing. You can write it just like this, and it is a comparison of two numbers. And then, of course, if we're saying we can compare them by division, the third way would be to write it like a fraction. Except we would not read this as 2/3. You're still going to read it as 2 to 3. All right? This would be saying for every 2 tests we take, we have 3 homework assignments. Okay? So you have a ratio of test to homework as 2 to 3. You can write it either of these 3 ways.
Or like for every 2 miles you walk, you have to rest for 3 minutes.
There you go. Absolutely. Okay? So a rate is now a specific type of ratio. So a ratio comparing two quantities with different kinds of units. So like measurement, okay? And that is units. I'm sorry. Make it look not like an M. So with different types of units. The most familiar one that you're probably used to seeing, when you get in a car or your parents are driving, to keep them from getting a ticket, what are they paying attention to? The speed limit. The what? Miles per hour. MPH. Okay? Miles per hour. This is a rate. And it's comparing miles, which is distance, and hour, which is time. So that would be a rate because it's comparing two quantities with different units. New store across the street. What is that? A gas station.
Which is the
Okay. What do you see on the sign outside? What else?
amount per gas.
Okay. So you're looking at the price per gallon. Okay? That is another example of a rate. Yesterday watching the Super Bowl. Okay? Yards per run. Is that a figure that they talk of sometimes?
Yes.
Or yards per play?
Yes.
Okay? How many yards they're averaging in every play? Okay? So you're measuring distance. Let's say per run. So yards per run, so distance over event. Okay? So two different types of measurement. Free throws. When you're shooting basketball, successful free throws compared to attempts. That's a rate. Points per game. Absolutely. That is a rate.
Rebounds per game.
Yeah. There you go. Any kind of stats like that involves a rate. Absolutely. Okay, so now what are we going to actually do with these? Okay? So looking at our examples, all right, we're writing a ratio as a fraction in simplest form. What does that simplest form tell me it's going to do? You are simplified. Okay? Then explain its meaning. And so we're going to talk about how to do that. Looking at this, it wants the ratio of pens to pencils.
6 to 8.
Okay? And so which one are you going to list first?
Your smallest.
Pens. No, you got to list the pens because it asks for the pens first. You've got to do them in the order they ask them. Okay, and it wants it listed as a fraction. So we said there are 6 pens to how many pencils? 8. 6 to 8. Now, again, using your handy-dandy calculator, if you are one of those people who tells me constantly I don't like simplifying, okay, we would write that as 3 to 4. Not 3/4, but 3 to 4. The ratio of pens to pencils is 3 to 4. Now, when we explain that, what it means is for every 3 pens, you have 4 pencils. You ever heard of something called student-teacher ratio?
Yes.
Okay. It basically means how many students there are per teachers in the building. Okay? So right now in this room, I'm just going to estimate, usually there's 29 of you guys. So there's a couple of desks empty. I'm going to say right now we have about 27. So right now, student-teacher ratio would be 1 to 27. Okay? Or 27 to 1, student-teacher ratio. Got to make sure you list it in the right order. So basically that's what we're saying here is to explain this. For every 3 pens, we have 4 pencils. Okay? Looking at the next one. What about pennies to dimes? 3 to 9. Look for Abraham Lincoln. 1, 2, 3, and the rest are dimes. Okay, so what ratio would this represent? 1, 2, 3. Be very careful, guys. I know it's don't say 1/3. Think ratios. You've got to call it 1 to 3. All right, I know you're so used to looking at it and saying it's 1/3. No, we want to look at it as a ratio of 1 to 3.
So next year, is that 1/3? Would they say that?
Well, now, right now, we're specifically talking about ratios. All right? When you're dealing with fractions, yes, it is 1/3. And if you look at that, that means 1/3 of those are pennies. But right now, when we're talking about a ratio, I want you to read it as 1 to 3. All right? Meaning for every 1 penny, you have 3 dimes. Okay?
So it'll be like we'll finally get this down and it's like we're going back to fractions.
No. All right. A theater is showing 8 romantic comedies and 12 action thrillers. What is the ratio of action thrillers to comedies? What has happened right here? What did they do?
Flipped it.
They flipped it. Okay? They listed the amounts to you in one order, but then they turned around and asked for the ratio in the opposite order. So be careful you're paying attention to what they're actually asking for. Okay? So what would my ratio be of action thrillers to romantic comedies? 12 to 8. Okay, now, pay attention to this. Let me show you one thing. I do agree, and I'll come back to that in just a second. All right, if you want to simplify 12 to 8 on your calculator, what's going to happen when I hit enter?
Syntax is inaccurate.
Nope. It's going to give you a mixed number. Guys, over here, no mixed numbers. And here's why. A ratio, by definition, compares what? Two things. I don't have 2 numbers here. Okay? I want 2 numbers and 2 numbers only. So you will have no mixed numbers. So you've got to know how to simplify when you're looking at an improper ratio. What number will go into 12 and 8? 4. 4 goes into 12 3 times. 4 goes into 8 2 times. So you have a ratio of 3 to 2. And again, you can write it any way. 3 to 2, 3 to 2, 3 to 2. All 3 of those things mean the same thing.
But wouldn't that the last one mean 3?
It's 3 to 2. Yeah.
Oh.
Again, just a different way to write the same thing. All right, last month Eduardo ate 9 apples, 5 bananas, 4 peaches, and 7 oranges. Find the ratio of bananas to the total number of pieces of fruit. So, okay, why did you say 25?
Because he ate, like, all of the fruit added up is 25, but, like, it's not going to be 20 because he ate bananas too.
Exactly. So, because it said the total number of pieces of fruit, we want 25. If it had said the ratio of bananas to other types of fruit, you could have left the bananas out. But it says total pieces of fruit, so you want to include the bananas. All right. So what's our final ratio? 1 to 5. Very good. And again, that means for every 5 pieces of fruit, you have 1 banana. And for those of you like wanting to make this like fractions so badly, if I had 5 pieces of fruit and one's a banana, 1/5 of them, 1/5 of the fruit are bananas. Does that make sense? Do you see how it's the same thing? You're just reading it differently. Yeah. Okay. And let's go and let's explain that one. So, for every 5 pieces of fruit, 1 is a banana. Okay? Now, I will go ahead and tell you 5 and 6 will be the hardest problems we'll do this week. Everybody good so far? I'm going to flip over to the back just so I have room. They're not hard. They just sometimes have a hard time people wrapping their brain around it, okay? So looking at number 5, it says divide 28 cans of soda into 2 groups so that the ratio is 3 to 4. All right, we're going to go ahead and we're going to give our soda names. We're going to say we have 3 Cokes and 4 Sprite. Okay? So, looking at this, if I have a ratio of 3 to 4, that means I have pulled out to the side. I have 3 Coke cans here, and I have 4 Sprite cans there. So how many total cans do I have right now? 7. Okay? But it wants to know what my ratio is going to be if I have 28 cans. So how do I go from 7 to 28?
You multiply.
Times 4. So that means I need 4 groups of these and 4 groups of these. All right? So if I multiply both of these, 3 times 4 gives me what?
12.
And 4 times 4?
16.
Do those two together equal 28?
Yes.
This is your new ratio. Good.
Is that really the hardest?
That is really the hardest problem to do this week.
Really?
For some reason, this one throws people off because then when they get to this point, they want to simplify. Well, what's going to happen if I simplify this?
You're going to get back to
I'm going to go right back to 3 to 4. And I don't want to do that. I want my new ratio that totals 28.
The problem is like the math problem is you're unsimplifying.
Exactly.
So how would you re-simplify?
Absolutely. And if you look at it this way, every time, so if I start off with 3 Cokes and 4 Sprites, and I add 3 more Cokes, what do I have? 6. And I have to add 4 more? 8. So I add 6 more, I have 9 and 12. See how each time I'm adding the same of each? And then this time I start off with 7. Now I have 14, 21, and 28. Okay? So basically what you're doing is you're adding a whole other group. You're doing plus 3 each time and plus 4 each time.
So basically, if I wanted to have 9 Cokes,
You'd have to have 12 Sprites.
What do you want us to do?
Yeah.
It's basically saying, so if I multiply 3 by 2, you have to multiply 4.
Absolutely. Because you want to keep the ratio the same as 3 to 4.
It's like a constant.
Mm-hmm.
Where should we do our homework?
Hang on. All right, let's look at number 6. Okay. Baking. So we've got 18 cups of flour. And we want to maintain our ratio of 4 to 5. Okay, so let's say we've got almond flour and all-purpose. All right, and we have 4 cups of almond flour and 5 cups of all-purpose. So how many total cups do I start with? 9. Okay, hang on. And I want to go to 18. So how do I go from 9 to 18?
Multiply by 2.
Okay. So I have to do the same thing up here. So what's my new ratio?
10.
Does that equal 18? There you go. That's your new ratio. So for every 4 cups of almond flour, you have to have 5 cups of all-purpose. Okay? Wait, she's Alright, I'm going to stop this. Yes, your homework, you can start that on a sheet of blank paper.
So if I